Why do jet engines create condensation trails, contrails? Imagine flying high above the clouds and suddenly seeing long white streaks trailing behind the airplane. Those streaks are called contrails, and they tell us a lot about how gases and phase changes work in the atmosphere. When a jet engine burns fuel, it produces hot gases filled with water vapor and tiny particles. As this hot, moist exhaust mixes with the cold, humid air at high altitudes, something interesting happens. The water vapor cools down quickly because the surrounding air is often below -40 degrees Celsius. When water vapor cools past a certain point, it turns into tiny droplets or ice crystals, depending on how cold it is. These tiny ice crystals are what we see as contrails. They form because the water vapor in the exhaust condenses onto small particles called condensation nuclei, which are often soot or other aerosols from the engine or the atmosphere. These particles act like tiny landing pads for water vapor, making it easier for the vapor to turn into liquid droplets. At the very low temperatures found high in the sky, these droplets freeze almost instantly into ice crystals, creating those bright white streaks. From a thermodynamic point of view, this is a phase change, water changing from vapor to liquid and then to ice, driven by temperature and pressure shifts. When the hot gases from the engine mix with the cold air, the temperature drops rapidly, and the air becomes supersaturated with water vapor. That means it holds more moisture than it normally can at that temperature. This excess moisture condenses onto the particles, forming tiny droplets that quickly freeze into ice crystals. The presence of aerosols from burning fuel makes this process much easier because they provide surfaces for condensation. Without these particles, water vapor would need much colder or more humid conditions to condense directly into droplets. The ice crystals then stick together and form visible contrails. These contrails can last for a while depending on the atmospheric conditions. If the air is very humid, the ice crystals may stay and spread out, sometimes forming clouds that look like cirrus. If the air is dry, the contrails might evaporate quickly. So, in simple terms, contrails are a result of the water vapor in jet engine exhaust cooling down and changing phase from gas to ice crystals, thanks to the cold, humid air at high altitudes. This process is a perfect example of how gases and phase changes work in the atmosphere, influenced by temperature, pressure, humidity, and tiny particles that help water vapor turn into visible ice clouds. The more efficient the engine, the cooler the exhaust gases tend to be, which can make contrails form under a wider range of conditions. The sulfur content in the fuel also plays a role because it influences the number of particles in the exhaust that can act as condensation nuclei. Understanding how contrails form helps us see how gases and phase changes interact in the environment, and also shows us how human activities like flying can impact climate by creating these reflective ice clouds.